this video, we're going to be looking at an introduction to our second unit, regression. When we want to think about what we're doing here, we're looking at a larger picture of statistics. So I kind of define my own version of what statistics as being is trying to make sense of the world around us given limited information. Now, sometimes what we want to do is we want to try to take information that we have and create a model of it to either understand a process or possibly to predict what might be going on in the future. So in order to do that, we take a bunch of data in, and then we try and find the mathematical equation that is going to best fit that information. We can kind of think that in Unit 1, when we had single variables, what we did was we made a histogram, and then we said what distribution fits best over top of them. Or we were looking earlier at, maybe I had a uniform and I had made a histogram and things kind of looked like this. What might I say this is close to approximated by? Maybe I'm going to fit a uniform distribution on this. Probably one that doesn't go quite as long. Or maybe I have another distribution where I have something that looks like this. I might decide, oh, this looks like a normal distribution fits best on top of it. But in both of these situations, I have exactly one x, and I'm trying to make sense of its distribution, which is going to be our y. But what happens when I actually have a literal y variable? Here we're letting y take care of our count, and it's not something that is its own random variable. What if it actually is a variable in its own right, and I want to look at the relationship between my y and a new x? So this is our idea of going from curve to line. So instead of having a histogram and trying to fit that smooth shaped curve over it, we're going to look at a situation where we have two variables and we're trying to decide how are they related to one another. Knowing what I know about x, what does this tell me about the likely value of y? So instead of making a histogram, because I actually have two axes that I need to give their values in their own right for, when we have this xy related pairs, we're going to look at a graph called a scatter plot. So scatter plots, you've seen at some point before, even if you're possibly forgetting what the definition is right now off the top of your head. So we're looking at our relationship between two quantitative variables, and our scatter plot, you can think in our head, it's going to be used in order to find some xy's. So I'm going to have a bunch of points, and each of these points are going to have some sort of xy coordinate. So this is my 6 observation, maybe this is x6 and y6. And this one has coordinate x1, y1. So I am trying to show what my relationship is by looking at the point that I have single observations that simultaneously have an x and a y value. So how many hours you work and your hourly wage, the temperature of your oven and the amount of time it took your cookies to bake, the number of products that you bought versus the number of products that you sold. So we're looking at, for a single piece of observation, a conjoining x and y that I'm going to put onto my graph. Now, if we have a situation where we have one of our variables, x is an explanatory variable, and our variable y is a response variable, traditionally we will put the explanatory variable on our x-axis. And if I have a response variable, we're going to put that on our y-axis. However, if you don't have an explanatory and a response variable and you just have two related data points that you want to match up, it doesn't particularly matter which axis you put them on. In this unit, we're going to be looking at where we care about our axes being used to predict our y, because we're talking about prediction and modeling, but that might not always be the case when you're making a scatter plot. So let's take a look at this using our example we're going to be using for this unit. So this is about examining the relationship between a country's fertility rate, average number of children per adult female, and their life expectancy. So we want to think the average lifespan of these citizens. So we're going to obtain the bunch of data, my country, my fertility rate, and my life expectancy. So we want to think where this is the average number of children per adult female, and this is the average lifespan of the citizens. And I have this information for 8 different countries. So each country has its own X point and its own Y point, and they are paired together. So this will represent 1 point on my axis, 3.2, as well as 62.5. So I have 8 different countries, so I will find that I'm going to have 8 different points on my scatter plot. So let's go take a look at what the scatter plot looks like, and let's try to find that point, 3.2, 62.5. We have our 2 axes, our fertility rate and our life expectancy plot. We're using the fertility rate to try and predict the life expectancy. This makes sense. People first have children and then they die after they have their children, so it wouldn't make sense for when they die to explain when they had children. If I have something that's happening in sequence and in time, generally speaking, our first one is going to be our explanatory variable, and our second one is going to be our response variable. Now I can go through this and I will notice that I have 1, 2, 3, 4, 5, 6, 7, 8 different points, each one representing one of our 8 different countries. And we said we were going to go look for that 1 point at 3.2 and 62.5. So let's take a look. Where would be the one at 3.2? So something a little bit above 3. Where is it going to fall on my axis? That's more or less halfway through that 62.5. So this will be that point, 3.2, 62.5. And we could identify 1 point for every single one of the countries that we are interested in. Now, looking at these points, why did we make the scatter plot? Is we want to get an idea of what kind of model we might like to fit. What do I think is the best relationship for this? Remember, I thought there was a relationship between my X and my Y, my fertility rate and my life expectancy. So I went and I gathered some data. Now I'm going to visualize the data set in order to have an idea for myself about what kind of model I would like to put. And if we look at this, this looks like our points are kind of going in a line. That if I was just eyeballing things here, I could probably put something like, pretend I was drawing a straight line, something like this through my data points. That would be a pretty good summary of the relationship that they're having. So I can note that I'm going to have a relationship that appears to be linear. I'm also going to notice that it looks like it is a negative relationship. So I can think that as my, what does this mean? As my fertility rate goes up, what happens to my life expectancy? My life expectancy is going to go down. They move in opposite directions from one another. So as my X goes up, it's increasing from 2 to 5. My Y is going to go down. It's going down from 80 to 50. When they move in opposite directions, we'll call that a negative relationship. And not only that, but we can see that it looks like it's a pretty strong linear relationship. Our points aren't very far away from the line. They're not really spaced out. They're actually following it pretty closely. So I'm going to have a pretty good idea that my model's going to be linear, and that's what I want to fit. It's going to be a negative relationship, and I think it's going to be a pretty good fitting model. I'm not guessing at the relationship where the slope is going to be. It looks pretty clear to me what's going on in this question. Now, if I want to recreate that graph, not by hand using R, we can make use of the plot command. So plot XY. So I plug in X and Y, the name of the vectors that I make that contain my X data and my Y data. So in our example, we had information on the fertility rate and the life expectancy. So I created a vector called fertility. This is going to be my x. Then notice, because it's a vector, it's a string of a single variable worth of data. I use the C bracket command to create a vector for a single string of data. And then I do the same thing for life, my y. I use the C command for the vector to make that single variable worth of data. And then I use that plot, comma, x, y. R is only as smart as you are. It will still make the plot if you put them in the opposite directions, but you're going to have the things on the wrong axis. So this is up to you to identify that you have put things correctly, exactly where you want them. But this is the code that I use to produce that plot. So again, to summarize from our scatter plot, we saw that we had a negative relationship. We saw that the relationship was linear, and that it seems to be a fairly strong relationship. Now this is all just by visual inspection. We're going to need ways to quantitatively and objectively determine these things, and that's what we're going to be looking at in this unit. So, and think, great, I've identified two variables of interest to me, and it appears from my scatter plot that there's a linear relationship between two of them. So my next step is going to be I'm going to propose a model about how I believe the x and y relate to one another. Spoiler alert, it's going to be a line. And then we're going to decide how am I going to fit the best fitting line to that data, which isn't me trying terribly to make a straight line freehand with an Apple Pencil on my iPad. We're going to try and use an objective math way to find what is that best fitting model to the points that I have. It is the unfortunate part of stats that data visualizations can fool you, that you can have people purposely try to mislead you. Things can be difficult to decipher. So we want quantitative, objective ways for making these decisions. And that's what we'll be doing in the rest of our videos for this unit.